Welcome friends. So far we discussed about various stages in the development of manufacturing strategy, and in last few sessions we discussed about a very important aspect on which the concept of excellence is based, and that important concept was the concept of quality. We discussed in detail about what is quality, how the quality has developed or evolved in its present form, the contribution of some of the important quality gurus, and then we also discussed finally that how you can see that quality is finally implemented in the processes of the organization. And in our last session where we discussed about some business excellence models, one important thing I will like to remind you that most of the organizations or most of the awards are focused about processes, that how are we improving our processes, because the whole idea is not about improving the product, but improving the processes. Improving the processes, how to improve the capability of the process so that you can achieve the objective of prevention, and therefore there is less requirement of detection. So, this is one very important phenomena we need to keep in mind, that processes are very important thing. If you have sound processes, if your process capabilities are higher, then your output will also be good. So, your output depends upon your process, and if you do not have appropriate processes, however good quality product you have designed, you will not be able to deliver that quality product. But if your processes are good, then only you can make that product, then you can deliver that product without much detection requirements. So, therefore, processes play very important role in our manufacturing excellence journey, and this particular session is focusing on choices of processes. So, we will discuss a very important issue, that how do we make choice for a particular process. Now, when we see the choice for a particular process, so this particular figure comes to our mind, where we have a very conventional framework of manufacturing strategy, or you can say generic manufacturing strategy. We already have few classifications of manufacturing strategies in our previous sessions. We discussed different authors' taxonomies related to manufacturing strategy, but one very particular, one very popular taxonomy, you can say one very popular classification of manufacturing strategy, you say, is available on the basis of process choice. And let us see what is this conventional framework of manufacturing strategy. Now, in this conventional framework of manufacturing strategy, we have two dimensions. One is this process dimension and another is this product. Now, based on this, we call it product process matrix. The name is product process matrix, that is the name, and that is a very popular way of defining your generic manufacturing strategies. Now, what is this product process matrix? You see, there are different types of product examples which are available in front of us. Now, what are these? Like, one type of products are low volume, low standardization, where volume of each product is less, you are producing in smaller quantities, and standardization is also not there, or you can say low standardization means more customization. So, as per the requirement of customer, you can offer different types of products, but since volume is low, so obviously you can fulfill the requirement of a large number of customers, because they all require different types of product. So, each product is required in less quantity, therefore, it is low volume and low standardization. Then you go to the second category, that is multiple products, low volume. Here you have again low volume, but it is not exactly low standardization, but you have slightly some specific type of products, but volume also increases from this first category to second category. So, more volume and some multiple products are there. Now, then we move to third category, where we have few major products and higher volume. Now, the volume increases, and when volume increases, the number of variety decreases. So, variety and volume are inversely proportional in this discussion. If you have less variety, you produce in very high volume, and that is the fourth part. In this fourth point, you see that we have higher volume and high standardization. Higher volume, high standardization means you are producing in large quantities, and you have very high standardization means variety is very less. You are producing only very limited type of varieties of the product. So, from 1 to 4 you can see that our volume per type of variety is increasing, and therefore, number of varieties are decreasing. As we are coming to point number 1, we can see that volume per variety is very low, therefore, varieties are very large. And as I go to point number 4, the volume per variety is very high, therefore, varieties are very less. So, these are different types of combination of volume and variety in our manufacturing organization, and on the basis of these volume and variety, you have different types of processes. Now, when we have low volume, low standardization, we have job shop type of production system. We have a very flexible type of production system, because volume is low. So, there is no need to have a production system which can automatically produce large number of quantities. Each time I get a different type of product design, and therefore, my production system, my process should be able to facilitate the production of unique designs. So, the job shop jumbled flow is suitable type of process for this kind of volume requirement. So, this is 1:1. Then second type of process is batch or disconnected flow lines. So, this is second type of production system, where you have some products variety is still sufficiently large, but volume is also considerably okay kind of thing. So, this is the batch kind of production, like you have example of some kind of pharmaceutical production etc., where we have batch production, and one particular pharma company is making large number of medicines. So, each batch has significant number of production. So, that is the batch or disconnected flow kind of process arrangement. Then third is few major product lines, and for that purpose you have assembly line and connected line flow system, that is the third type of arrangement. So, this is suitable for this type of volume variety combination, that is the assembly line or connected line flow system. You are making one particular type of product for long duration. So, that is normally possible in assembly line system, and our automobile sector is a very good example of this third category, where you have assembly lines to assemble the body of the car, you have assembly line to assemble the engine or some other kind of components. So, that is for few major products, and volume of each product is also significantly high. And then we have the fourth category, where you have very high volume of production and high degree of standardization, and this is possible because you have almost no variety, and in this case the process which we follow is the continuous flow. That continuous flow process is suitable for this fourth case, where your volume is also very high and you do not have any variety and only one type of product is continuously produced in your organization. So, this is the fourth type of process. So, you see that these four processes are connected with four different types of product variety combinations, and therefore, you see that examples are also available, that how we have seen that different types of examples are there, that here in this particular case we have this center line which is giving you that for continuous flow where we have very high volume, the example of sugar refinery. So, this is for fourth case, that sugar refinery no variety is there, or you have only one type of sugar coming continuously from that refinery. Another example where only one or two type of products are coming and you have same process for all the varieties. Automobile assembly, we already discussed that for third type of case where few variety is there, but volume in each variety is also sufficiently high. So, that is the automobile assembly lines. Then heavy equipment or even in the case of your pharmaceutical manufacturing, we will find this type of multiple products and each product has very low volume of production at a particular time. So, in heavy equipment industry where you are making things like let us say blades for turbine, transformers, etc. So, these are the examples of batch and disconnected flow. And then the tool room, where you have each product coming with unique requirement, that is the job shop kind of arrangement, and that is the first type. So, depending upon the process choice depends upon your product variety, or you can say volume variety combination. Depending upon your volume and variety, you will select a particular type of process. So, this is our conventional framework, which is a two-dimensional framework. It is a two-dimensional framework. The only thing in this is we are considering variety and volume. So, this is a two-dimensional framework, and since long, if you go to textbook of operations management, you will find only this two-dimensional way of understanding our process choice, that is based on volume and variety. Now, there is some research happening in the development of new frameworks for these generic manufacturing strategies, and under this new frameworks for generic manufacturing strategies, we are now trying to consider few more dimensions. And now, if you see that apart from manufacturing skills, organizations require some other capabilities also, and where if you see that in research, what are the different types of researches which are available related to validation, empirical validation I am talking for process product framework. These are only 3 studies, and all these 3 studies are contradicting in their findings. Some of the studies have validated the choice of process based on variety and volume, and some of the studies have not followed. But since only very limited number of studies are available, we cannot reach to any conclusion just by 3 studies, and those 3 studies are also not in sync with each other. So, this is a two-dimensional, this product process framework is not sufficient, maybe because it is not very comprehensive framework, and when people started empirically validating it, then they realized that it is not a very comprehensive way of selection of process. So, we have also realized that there is sufficient influence of market on the manufacturing, And in our so many last sessions we have discussed that there is a need of manufacturing to be market driven, and with that idea this new framework is being proposed, and where we have three dimensions. One dimension is about the process related thing, which is already available in our previous two dimensional framework. The other is related to product line complexity, and third is related to organizational scope. So, there is some changes in the nomenclature, and at the same time there is addition of one more dimension. So, now we have a three dimensional framework for generic manufacturing strategy. So, this you can say our movement from the traditional 2D to this enlightened 3D view of generic manufacturing strategies. Now, what is it this generic manufacturing strategy in a three dimensional case? Now, here we see this three dimensional framework and we have tried to map our conventional product process matrix on this three dimensional generic manufacturing strategy system. Now, here you see this line which is known as our x axis, it is representing the product line complexity, and the y line is representing the process complexity, and the z is representing the organizational scope. So, here we are having three dimensional view, and therefore, it is not a 2 by 2, it has become a kind of cube in its understanding, and you have 8 corners of this cube, and these different corners are giving you different type of generic manufacturing strategy. And when you see that our conventional product process framework, so from this corner where you see the job shop. Now, in this job shop, if you go to this corner, the top corner of this side of this new cube framework, in this job shop represents that you have very low volume and high variety. This was the conventional way of understanding the job shop, that you have low variety and very high variety and low volume. Now, here you see the product line complexity. When you are offering large number of varieties, you have very high complexity, and therefore, this is coming on this side of this framework where you have very high line complexity towards 8 or 6, both these points are falling in the same straight line. So, that is the high line product complexity. Then you see the process complexity. Process complexity is moving from high complexity to low complexity, because each product requires a different kind of manufacturing processes, and you have mostly the flexible manufacturing system in case of this job shop kind of production environment. So, you have limited or low process complexity. So, therefore, you are combining this low process complexity and this product line complexity, high product line complexity, and therefore, you are reaching to this point number 6 here. And just to come to this end point, point number 7, where we are talking of continuous production. Now, in continuous production we are having very limited variety and the volume is very high. Now, when we are talking of limited variety, the product line complexity reduces very much. You are only making 1 or 2 types of products, sugar for an example. So, very limited variety you are making. So, the product line complexity is very low, and process complexity, if you visit a sugar factory, you know that how complicated the plant is because of high standardization of your processes. So, therefore, you get a highly complex process and very low product line complexity, and therefore, it comes on this point number 7 when we are talking of continuous production. And we will also add the dimension of organizational scope, and for that purpose let us first try to understand the meaning under this 3-dimensional GMS, what is the meaning of process complexity, what is the meaning of product line complexity, and what is the meaning of organizational scope. So, let us see that first. Now, when I am saying the process structure complexity, now the process structure complexity is seen to be low and high. Now, low and high process structure complexity means that an immature process, one exhibiting many discontinuities between processing stages. So, that is the low process structure complexity, and high process structure complexity, a mature process used in the production of commodity like items characterized by interconnection of processing stages. So, where you have more interconnectedness between the process stages, that is known as high process structure complexity. And obviously, if you go to a refinery, if you go to a sugar factory, if you go to a paper mill, you will see that stages are interconnected one after another, and the whole things are arranged in a very systematic manner. So, therefore, these are high process structure complex systems. On the other hand, if you go to a tool room, you will see that there are large number of stand-alone machines, and depending upon the requirement of each new object, these processes are decided, and therefore, lot of discontinuity is there between processes for each product. So, therefore, these are characterized as low process structure complexity. So, this is about process structure complexity. Then the second dimension in this 3D view is product line complexity. Now, the product line complexity is the measure of type and variety of the product lines. So, it takes care of your marketing dimension, that how many types of products you are offering, how many type of variants you are offering. So, we need to go to the concept of product line, where you may have different types of products A, B, C, and in each you may have different types of variants like this. So, depending upon what type of product line you have, you will decide your product line complexity. So, complexity of end products, variety or number of end products produced, individual product volumes, and end product maturity or experience. So, the product line complexity is made of all these things. Now, when we have, obviously you can understand, if you have a product line where you are having A, B, C, D, E, F products, and for all these products you have different variants available. So, you have a highly complex product line, because different products, their different variants may be at different stages in their product life. On the other side, if you have very limited number of products, or if you have only one product in your product line, your product line complexity will accordingly be much less. So, if you recall in our discussion, when we are saying the continuous production on point number 7, it has low product line complexity, because you have very limited or only one or two types of products. When we are saying the product line complexity high, and we are taking the example of job shop, because in job shop you have almost infinite number of jobs, you cannot say that how many jobs you are producing, and therefore, you are going towards the product line complexity, high product line complexity side. So, that is depending upon the variety, the number, the volume, and the stages of these products in their product life cycle. So, that is about the definition of product line complexity. Then the third important dimension is the organizational scope. Now, organizational scope is measured in two terms, and these two dimensions, earlier two dimensions, product line complexity and process complexity, are related to our product process discussions. But this is a new dimension we are adding, and that is geographical scope of the organization. So, geographical scope is related to your market, that how much market, where is the market of the organization, and the second is level of vertical integration, that what level of vertical integration you have in your organization. So, like you have this supply chain where you are this OEM, then you are having a wholesaler, a retailer and a supplier. So, the meaning of vertical integration is that you may move to acquire the business of your wholesaler, you may become a distributor of your own products, or you may start making the components which are being supplied by your supplier. So, level of vertical integration, whether it is forward or backward, how much integration you are doing in your supply chain. So, that is the meaning of organizational scope. So, that is a third dimension which was not there earlier, was added into this generic manufacturing strategy framework for 3 dimension. So, based on that we have 8 points. If you remember in that cube structure, we have these 8 points 1, 2, 3, 4, 5, 6, 7, 8. Now, these 8 points will give us 8 different types of characteristics with respect to these 3 dimensions. Like if I talk of point number 7, the point number 7, and if I include all 3 dimensions, so this is a point which is characterized by low product line complexity, it has high process complexity and it has high organizational scope. Similarly, point number 3, it also has high process complexity, it also has low product line complexity, but the organizational scope is low in this particular case. So, by this way we will be having different types of combinations for these different corners of this cube. So, we will be discussing these 8 different types of generic manufacturing strategy in our next session, where we will see that out of 8 these corner points, some of the points are actually those points where an organization will like to go, and there may be some points where we may not be willing to go, and if we are moving towards those points, we need to see that how we change our direction and go to some other desirable points. So, that all we will discuss in our next session. Here we come to end of this session. Thank you very much.